The $10 quintillion metal asteroid is rusting. Analysis from the James Webb Space Telescope reveals signs of water in the form of rust on the giant metal-rich asteroid Psyche. Scientists using the James Webb Space Telescope, JWST, have identified the presence of water on the metal-rich asteroid Psyche. Live Science reported on August 14th. The discovery indicates the presence of hydration in the form of rust, potentially revealing insights into how this celestial body formed. 16 Psyche is quite unusual compared to the main asteroid belt between Mars and Jupiter. With a size of 280 kilometers at its widest point, this potato-shaped body was once thought to be composed entirely of metal. Psyche's extremely bright surface led researchers to speculate that it could be the iron-rich core of a protoplanet, providing clues about how Earth and other rocky planets formed. Some researchers estimate that the rare metal content of Psyche could be worth $10 quintillion. In fact, the hypothesis about Psyche's composition is the driving force behind NASA's ongoing Psyche mission. Launched in October 2023, the spacecraft is expected to reach the asteroid by 2029 to study it in detail. However, over the past decade, new data on Psyche's density and reflected spectra, the intensity of various wavelengths of sunlight reflected from its surface, suggest that it is primarily composed of silicates mixed with metal. In 2017, researchers discovered traces of another component: water. Infrared spectra at long wavelengths, perceived by us as heat but not visible, revealed the presence of hydroxyl groups, or OH molecules, found in water. This finding suggests that Psyche's surface may contain small amounts of water, possibly as ice or hydrated minerals. However, data collected by NASA's Infrared Telescope facility in Hawaii may have been affected by water vapor in Earth's atmosphere. Additionally, researchers have not found clearer signs of water from higher infrared wavelengths, according to Stephanie Jarmack, a planetary scientist at the Harvard-Smithsonian Center for Astrophysics. To determine whether Psyche truly contains water, Jarmack and scientists from several US and German institutions used two of JWST's sensors, the Near-Infrared Spectrograph, NIR-SPEC, and the Mid-Infrared Instrument, MIRI, which can detect shorter and longer infrared wavelengths. By pointing these instruments at the asteroid in March 2023, the team collected reflective spectral data from Psyche's northern hemisphere, which was facing the telescope at the time. Their findings will be published in the Planetary Science Journal. NIR-SPEC data revealed signs of hydroxyl, confirming the presence of water on the asteroid. Additionally, Jarmack explained that the high-quality data allowed for comparisons with hydroxyl signatures from other rusted carbon-rich meteorites. The research team concluded that the hydroxyl on Psyche is bonded to metal, forming rust. However, MIRI data was inconclusive. It's possible that water is present, but at a density below MIRI's detection limit, less than half the water density on the Moon, equivalent to a raindrop on a kilogram of soil. Beyond causing rust, these hydroxyl groups also provide clues about Psyche's formation process. If the hydroxyl formed inside the asteroid, Psyche might have originated in the cold outer edges of the solar system and migrated inward over millions of years. Current evidence suggests that a water-bearing object may have collided with Psyche. Future plans include studying where exactly the hydrated metals are located on Psyche's surface, including observations of the asteroid's southern hemisphere, where numerous craters may have resulted from impacts with water-rich objects. Despite its estimated value, Psyche is not among the targets for space mining, as it lies 3 times farther from Earth than the Sun, making it too distant to mine cost-effectively.